Welcome students to online classes of mathematics for class 9th. In this video we are going to study chapter number 8, which is quadrilaterals of NCERT textbook, and we will be covering the first midpoint theorem and the few questions of exercise 8.2. That's why I have written it as part 1 of exercise 8.2. This is session number 4 for this particular chapter. Myself Deepak Gautam, teaching mathematics in Kendriya Vidyalaya Sangathan. So I start with today's class. So the first topic that we are going to study is the theorem 8.9, which is also known as the midpoint theorem. Okay, this theorem is commonly known as midpoint theorem. Okay, the statement of the theorem is the line segment joining the midpoints of two sides of a triangle is parallel to the third side. Okay, that means suppose we have this triangle A, B and C, where this E and F are the midpoint of the side AB and AC respectively. Okay, the statement says the line segment joining the midpoint of the two sides. So we have two sides AB and AC and their midpoints are E and F. Okay, and say that is parallel to the third side. So that means when you complete this side, you will get a side which will be parallel to the third side. So this side is we have got by the joining the midpoint of AB and AC. The remaining side is BC. That means this side is parallel to BC. Okay, that's what the midpoint theorem says. Okay, it says the line segment joining the midpoint of two sides of a triangle is parallel to the third side. That means if you join the midpoint of these two sides by a line segment, okay, this line segment will be parallel to the third side of which we are not taking the midpoint. Okay, so this side EF will be parallel to BC. That's what the theorem says. Okay, now we are going to look at the proof of this theorem. Okay, let's erase these marks. Okay, so first we'll start by writing the given part. So let's write given. Given here is a triangle ABC in which a triangle ABC in which E and F are the midpoints of side AB and AC respectively, which means this E is a midpoint of AB and F is the midpoint of AC. Okay, so we got a triangle ABC in which E and F are the midpoint of the side AB and AC respectively, and we have to prove that EF is parallel to BC. Okay, that's what we have to prove, that because EF is a line segment joining we got by the join the midpoint of two sides, and this has to be parallel to the third side. Okay, so we have to prove that EF is parallel to BC. So we'll start with the construction. So we'll do a construction. Construction here is from will extend or produce this side EF to a point D such that this CD is parallel to AB. Okay, so construction is produce EF to a point D such that CD is parallel to BA. So by construction we have drawn this CD, this line CD, which has to be parallel to AB. Okay, this is by construction. So first we've extended this, we have produced this EF to a point D such that CF is parallel to AB, or you can say BA. Okay, now let's start its proof. In its proof, what we're going to do is we're going to start with these two triangle AEF and triangle CDF. Okay, so and we'll prove that these two triangles are congruent by the property angle side angle. Okay, so we'll use that. First we have these two angles equal because they are vertically opposite angle. Then we have this side AF and FC equal because F is the midpoint of AC. Okay, so the both part will be equal. Then we'll prove that these two angle A and angle C are also equal because we have, by construction we have taken that AB and CD are parallel, then AC will be their transversal, so angle C and angle A will be the alternate interior angle. Okay, so by that we'll prove that these two triangles are congruent. So let's start. In triangle, first we'll take triangle AEF and triangle DCF. In triangle AEF and triangle DCF, what we have is that the angle, right, we have angle AFE is equals to angle CFD. Okay, because they are vertically opposite angle. Okay, these two are the vertically opposite angle. Then we have side AF is equals to FC. Okay, because F is midpoint of AC. So what we got is, we got an angle here A. Okay, we got an angle here, and here we got a side. Okay, now we come to the third one. Like in this diagram, we have taken that these two sides are parallel. If these two sides are parallel, then AC will be its transversal. So right, since CD is parallel to BA and AC is a transversal, therefore the angle EAF will be equals to angle DCF. Okay, EAF will be equals to DCF because they are alternate interior angle. Okay, so the angle AEF, which is this one, sorry, EAF is this one, and angle DCF is this one. So we already proved that these two angle and the side are equal. So we already got this angle side, and now we got another angle. So we can say that therefore triangle, we have taken a triangle AEF and DCF. Triangle AEF is congruent to triangle DCF. Okay, and that's by angle side angle congruence rule. Okay, once we have proved that these two triangles are congruent, then their corresponding parts, that is, this implies that the side EF is equals to DF. Okay, this EF will be equal to DF because they are the corresponding parts of congruent triangle. So right, CP CT, corresponding parts of congruent triangle, are equal. Also we have here that since this E is the midpoint of side AB, so we'll have that AE will be equals to BE. Okay, and since we have proved that these two triangles are congruent, therefore the corresponding side, this DC and AE will also be equal. So AE will also be equals to DC. Okay, these two sides will also be equal because they are the again corresponding parts of congruent triangle CPCT. So from here you can see that this is AE. You can see that this AE is equals to BE and AE is equals to DC. Okay, both are equal to same thing, that is AE. BE is equals to AE, DC equals to AE. So therefore, or you can write or yet this implies that the side BE is equals to DC. Okay, the BE will be equals to DC, and they are already parallel. Okay, and they are parallel. So what we got here is one pair of opposite side is equal and parallel. So we can say that therefore BCDE is a parallelogram. Okay, reason for this one is one pair of opposite side is equal and parallel. Okay, this is the theorem 8.7, which says I think it's 8.8. The theorem 8.8 say if one pair of opposite side of a quadrilateral is equal and parallel, then the quadrilateral is a parallelogram. So what we got is one pair of opposite side is equal, and we have already know that, like I've written here, that C and these are parallel. So we got these two sides parallel and equal. Okay, this BE can be is the half of the side BA. Okay, so we got one pair of opposite side equal and parallel, therefore we can say that this BCDE is a parallelogram. Hence its other two opposite side, that is EF, will also be parallel to BC, and that's what we were asked to prove. Once we have proved that this is a parallelogram, so its opposite side will be parallel. Okay, that's what we were asked to prove here, that EF is equals to BC, and since we have proved that this is a parallelogram, so its opposite side EF will be parallel to BC. Okay, we have got one more conclusion from here, that also this EF will be equals to the half of this EF here is equals to half of ED. Okay, and ED is the opposite side of parallelogram. Since we know the opposite side of parallelogram are equal, so ED is also parallel to B, so we can write this as EF is equals to half of BC. Okay, so that's the another conclusion from this theorem. So what we got is here from here is, in midpoint theorem, when you join a midpoint, the two side that you will get a line segment which will parallel to the third side. Okay, and also that line segment will be half of the third side. Okay, the conclusion from here is, when we join the midpoint of two sides of a triangle, that will be parallel to the third side and also half of the third side. That's what we got here, that EF is half of BC and EF is parallel to BC. They are parallel and they are that EF is half of BC. Okay, parallel and half. That's what the theorem 8.9 says, and it's called as midpoint theorem. Okay, now moving ahead to the theorem 8.10, this theorem says a line drawn through the midpoint of one side of a triangle parallel to the another side bisect the third side. Okay, so simply it's saying we have a triangle. Let's draw a simple figure of a triangle. Okay, let's name it A, B and C here. So it's saying the line drawn through the midpoint of one side. That means we are taking, let's say, the side AB and its midpoint is the point E here. Okay, so it's the line drawn through the midpoint of one side. So we will draw a line to the midpoint of one side, and this line has to be parallel to the another side. So this line is parallel to the another side BC. Okay, so it's saying the line drawn through the midpoint of one side. So we have taken a triangle ABC, and it's the midpoint of one side AB is point E, and through E we have drawn a line which has to be parallel to the another side. It means this line is parallel to this line BC. Okay, then it will bisect the third side. So when you draw this line, it will definitely bisect the third side. It means it will pass through the midpoint of the side AC also. Let's name it F. Okay, then F will be the midpoint of side AC. Okay, that's what this theorem says. Okay, in simple words says, if you have a triangle and from the one point or the midpoint of one side, if you draw a line which is parallel to the another side, it will definitely bisect the third side. Okay, that's what this theorem 8.10 say. Now based on these two theorem 8.9 and 8.10, which is a midpoint theorem, and this 8.10 is the converse of midpoint theorem. Based on this, we have exercise 8.2. So now let's start the exercise 8.2. This is chapter number 8, quadrilaterals, exercise 8.2. Here in this session we are going to cover the first three questions only. Okay, that's why I've written it as. Okay, now let's start with the question number 1. The question number 1 here is, ABCD is a quadrilateral in which P, Q, R and S are the midpoint of side AB, BC, CD and DA. So we have a quadrilateral which is given as here ABCD, in which P is the midpoint of AB, Q is the midpoint of BC, and R is the midpoint of CD, and S is the midpoint of DA. Okay, and then it say AC is a diagonal, so we have a diagonal AC. We have to show three things here. First one is that SR is parallel to AC, and also SR is equals to half of AC. Then we have to prove that PQ is equals to SR, and in the end we have to prove that PQR is a parallelogram. Okay, so let's start first writing the given part. Let's start the answer number 1. We'll mention the first given part. So given here is we have a quadrilateral ABCD. Okay, we have a quadrilateral ABCD. Given is a quadrilateral ABCD in which P, Q, R and S are the midpoints of the sides of the side AB, BC, CD, and DA respectively. Okay, that means this P is the midpoint of AB, Q is the midpoint of BC, R is the midpoint of CD, and S is the midpoint of DA. Okay, that's what is given in the question. Also we are given that and AC is a diagonal. Okay, AC is a diagonal. Now what we have to prove here is we have to prove three things. Let's try to prove. First we are asked to prove here is that SR is parallel to AC and SR is half of AC. Second thing we have to prove that PQ is equals to SR, and third we have to prove that Pqr is a parallelogram. Pqrs is parallelogram. Okay, so these are the three things which we have to prove here. So let's start the proof with part 1. We have proof of part 1. Here we have to prove that SR is parallel to AC and SR is the half of AC. Okay, so we'll write in triangle. We'll take that first triangle, this one, in triangle ADC, this triangle. Okay, in this triangle ADC, only this upper part of the triangle, what we have here is that since this S and R are the midpoint of the side DA and CD, that means if you apply the midpoint theorem, this side will be parallel to the side AC and also the half of AC. That's what we are asked to prove here. So we'll write simply in triangle ACD we have S is the midpoint of side AD and R is the midpoint of the side DC. Okay, midpoint of DC, or you can say CD. So we got two midpoint S here and R here, which are the midpoint of side AD and CD respectively. Okay, then so we got this triangle and in which S and R the midpoint of the side AD and DC. Okay, therefore simply directly applying the midpoint theorem, you can say that therefore the side SR will be parallel to AC and SR will be half of AC, and this is by midpoint theorem. Okay, the midpoint theorem simply says Theorem simply says the line segment joining the midpoint of two sides will be parallel to the third side, and that will also be the half of the third side. So we got the two midpoint of the two respective side, so that will be all parallel to the third side. Okay, and also in theorem we got that it will also be the half of the third side. So with this we have proved the part 1 that SR is parallel to AC and SR is half of AC. Okay, so let's name it equation 1 here also. This one is this collectively as equation 1. Then we have, let's start the proof number of part 2. Here we have to prove that the PQ is equals to SR. Now we are going to look at the triangle, this one ABC. In ABC, P is the midpoint of AB and Q is the midpoint of CB. So we'll write in similar way. Now in triangle ABC we have, in triangle ABC we have that P is the midpoint of AB and Q is the midpoint of BC. We have P is the midpoint of side AB and Q is the midpoint of side BC. Therefore again this side PQ will be parallel to AC. Okay, therefore PQ will be parallel to AC and PQ will be half of AC. This is again by midpoint theorem. Okay, directly applying the midpoint theorem we conclude that this PQ is parallel to AC and PQ is half of AC. Now let's name it equation number 2. Okay, so right from equation 1 and 2 we get, from equation 1 and equation 2 we get, what we get here is that you can see here that this SR is parallel to AC and PQ is also parallel to AC. So both are the parallel to same thing, AC and AC here. That means these two sides PQ and SR are also parallel. Okay, so from equation 1 and 2 we get that PQ is parallel to SR. Also you can see that this SR is half of AC. Similarly PQ is half of AC. So both are equal to the half of AC. That means the PQ and SR are also equal, and PQ is equals to SR. So what we got from the equation 1 and 2 that both SR and PQ are parallel to AC and AC. So that means they are also parallel, and both SR and PQ are equals to half of AC. That means they are also equal. Okay, so we'll write hence Pqr is so that's the proof of the part 2 of the question number 1, that PQ is parallel or equals to SR. That's what we are asked to prove here, that PQ is equals to SR. Now in third we have to prove that PQR is a parallelogram. Okay, now let's start the part 3 of question number 1. Now we have to prove that PQR is a parallelogram. Since we have got this condition here that PQ is parallel to SR and PQ is equals to SR, so we'll write that since PQ is parallel to SR and PQ is equals to SR, therefore PQRS is a parallelogram. This is by theorem 8.7, which says if one pair of opposite side of a quadrilateral, it says if in a quadrilateral one pair of opposite side is equal and parallel, then it's a parallelogram. Okay, the reason for this one is I'm writing it here. One pair of opposite side is equal and parallel. Okay, one pair of opposite side is equal and parallel, that's why this PQR is a parallelogram. That's what the theorem 8.7 says. I think 8.8. okay, 8.8 says the one if in a quadrilateral if one pair of opposite side is equal and parallel, then it's a parallelogram. Okay, so we already got one pair of opposite side is parallel and equal, so that PQR has to be a parallelogram. Okay, so that's the answer of question number 1. Now coming to the next question, question number 2, it says ABCD is a rhombus in which P, Q, R and S are the midpoints of the side AB, BC, CD and DA respectively, and we have to show that quadrilateral PQR is a rectangle. So it's given that it's a rhombus and we have to prove that it's a rectangle. Okay, given that we have 4 points P, Q, R and S, which are the midpoint of the four sides AB, BC, CD and DA. So ABCD is given as rhombus and we have to prove that PQR is a rectangle which is formed by the joining the midpoint of the all four sides. Okay, so let's start the answer number 2. First we'll mention the given part. Given here is a rhombus ABCD in which given is a rhombus ABCD in which P, Q, R and S are the midpoint of midpoints of sides AB, BC, CD and DA respectively. That's what is given in the question. We have to prove here is we have to prove that PQRS is a rectangle. So we have to prove that PQRS is a rectangle. Okay, now let's start this proof. So first we are going to do is we will prove that this PQRS is a parallelogram. Okay, using midpoint theorem like we did in the question number 1. Okay, first we are going to prove that this PQRS is a parallelogram. Okay, using midpoint theorem. So let's start. In triangle ABC, we'll consider this triangle first. Triangle, this one ABC. In this triangle we have, right, in triangle ABC we have P is the midpoint of AB and Q is the midpoint of BC. Okay, we have P is the midpoint of AB and Q is the midpoint of BC. Therefore PQ will be parallel to AC and PQ will be equals to half of AC. Okay, PQ will be equals to half of AC, and that too by midpoint theorem, which says the line segment joining the midpoint of the two sides will be parallel to the third side, and also the line segment will be half of the third side. Okay, next is in triangle, we'll take now the other triangle, which is the triangle ADC now. So in triangle ADC we have that R is the midpoint of DC and S is the midpoint of DA. We have R is the midpoint of DC and after R we have S is the midpoint of and S is the midpoint of DA. Therefore SR is parallel to AC and SR is equals to half of AC. This again by midpoint theorem. Okay, so what we got here is that PQ is parallel to AC and SR is also parallel to AC. That means we have studied in chapter 6 that one theorem that lines which are parallel to the same line are parallel to one another. Okay, so we have PQ parallel to AC and SR parallel to AC. This will give, so let's name it equation number 1 here and equation number 2 here. Now from equation 1 and equation 2 we get, what we get here is that, see here, this PQ is parallel to AC and similar way this SR is parallel to AC, so both are parallel to the same line. Okay, so that this implies that this PQ and SR are also parallel. Okay, then we have that this PQ is equals to half of AC here and also this SR is equals to half of AC, so both are equals to the same thing, therefore they are also equal. So right, PQ is equals to SR and so PQ will be equals to SR. So what we got here is PQ is parallel to SR and PQ is equals to SR, therefore we can say that this PQR is a parallelogram. Okay, so right, hence PQRS is a parallelogram. Reason for this one is if in a quadrilateral one pair of opposite sides is equal and parallel, then it's a parallelogram. So right, reason for this one is if in a quadrilateral a pair of opposite side is equal and parallel, then it is a parallelogram. Okay, the reason for this one, if in a quadrilateral a pair of opposite sides is equal and parallel, then it will be a parallelogram. That's a theorem. Okay, this is a theorem number I think 8.8, which says if one pair of opposite side of a quadrilateral is equal and parallel, it will be a parallelogram. Okay, so what we got here is a PQR is a parallelogram. Now come to this figure again. Now we are going to draw its one more diagonal. Okay, let's draw its second diagonal. Now we got this second diagonal DB of the rhombus ABCD, as it is given that ABCD is a rhombus. Okay, and we know that in rhombus the diagonals bisect each other perpendicularly. That means the angle here should be of 90 degree. Okay, this should be a angle of 90 degree, as we know that the diagonals of a rhombus bisect each other perpendicularly. Okay, let's name the point of intersection of the two diagonals as point O and this point as E here. Okay, and this one as F. So we got a quadrilateral which is EOFR. Okay, we got a quadrilateral EOFR, this one. Okay, so now we're going to work in this quadrilateral. Now let's see. Now let's write the diagonal of a rhombus bisect each other at right angle. Bisect each other at right angle. Therefore, from this figure, the angle this EOF will be equals to 90 degree. Angle EOF will be equals to 90 degree. Okay, now let's come to the triangle BCD. Now in triangle BCD, okay, in triangle BCD, which is this one, BCD is this one. Okay, so in triangle BCD, this Q and R are the midpoint of BC and DR. So we'll write in triangle BCD, R and Q are the midpoint midpoints of side CD and BC respectively. So okay, we got the 2 point R and Q, which are the midpoint of the side CD and BC respectively. Therefore the RQ will be parallel to DB, that is this side RQ, this one will be parallel to the diagonal DB. Okay, so now let's, from here we can write this implies, see from the figure, if RQ and DB are parallel, so we can write this as RE instead of RQ is parallel to, and instead of DB we can write FO. Okay, we are taking just a line segment of both the line. Okay, RQ is the line segment of RE, sorry, RE is the line segment of RQ, and FO is the line segment of DB. So they are also parallel. Okay, so from 2 we already have from in equation 2 that SR and AC are parallel. So from here we can write, from equation 2 we have that SR is parallel to AC, or we can write that one as, here we have SR is parallel to AC, or we can write this as, or FR is parallel to. So what we got is, we got the opposite side of the parallelogram, this small one, these two sides are parallel and these opposite sides are parallel. That means this FORE is a parallelogram. Okay, therefore OERF is a parallelogram because its opposite sides are parallel. Okay, so as we got in quadrilateral, the opposite sides are parallel, it will be a parallelogram. Okay, and in this parallelogram we already have that this angle is of 90 degree, and we know that in parallelogram opposite angles are equal, so its opposite angle R will be also be of 90 degrees. So we can write this as, okay, so what we got here is angle FRE is equals to 90 degree, and that will be equals to angle EOF. Okay, because they are the opposite angle of parallelogram, opposite angles of parallelogram, and we know that opposite angles of parallelogram are equal. Thus PQRS is a parallelogram, and that's what we are asked to prove here, that if PQRS is a parallelogram and with one of its angle, that let's say angle R is equals to 90 degree, hence PQRS is a rectangle. Okay, as we know, a rectangle is a special type of parallelogram in which all four angles are 90 degrees. So once you prove that one of the angle of a parallelogram is 90 degree, that means its all angle will be of 90 degree, hence it will be a rectangle. Okay, so that's the answer of question number 2. Now moving to the question number 3. We have in question number 3 we have ABC is a rectangle and PQR and S are the midpoint of AB, BC, CD and DA respectively, and show that a quadrilateral PQRS is a rhombus. So we are given that ABC is a rectangle and we have to prove that PQRS is a rhombus. It's converse or part, you can say, of question number 2, where we are given that ABCD is a rhombus and we have to prove that PQR is a rectangle. Now we are given that ABCD is a rectangle, we have to prove PQR is a rhombus. Okay, so let's start its answer. First we'll write the given and the to prove part. So let's write the answer number 3. Given here is a rectangle ABCD, a rectangle ABCD given here is a rectangle ABCD in which P, Q, R and S are the midpoints of side AB, BC, CD and TA respectively. And this is what given to us in this question. What we have to prove here is we have to prove that PQRS is a rhombus. To prove is PQRS is rhombus. That's what we have to prove. Okay, in order to prove that, first we'll prove that PQRS is a parallelogram in which all sides are equal. Okay, so first we'll prove that it's a parallelogram, then in that parallelogram we'll prove that it's adjacent side, or you can say all sides are equal, then will be a rhombus. Okay, so let's start its proof. Okay, so what we'll start with the same, applying the midpoint theorem first in triangle ABC and then in triangle ADC, like we did in the question number 1 and question number 2. So we'll write in triangle ABC we have, what we have here is that P is the midpoint of AB and Q is the midpoint of BC. We have is P is the midpoint of AB and Q is the midpoint of BC. Therefore what we have is that PQ is parallel to AC and PQ is half of AC. Let's name it equation number 1, and this is by midpoint theorem. Reason for this one is by midpoint theorem. Okay, this is by midpoint theorem. In similar way, you can apply the midpoint theorem in the triangle ADC. So right now in triangle ADC we have, okay, again applying the midpoint theorem now in this triangle. Okay, so here R and S are the midpoint of DC and DA. Here we have R is the midpoint of side DC and S is the midpoint of DA. Therefore this SR will be parallel and half of AC. Okay, therefore SR is parallel to AC and SR is equals to half of AC. Let's name it equation number 2, and that's again by midpoint theorem. Okay, so now from equation 1 and 2 what we get is, from equation 1 and equation 2 we get, what we get is that, now you can see that PQ is parallel to AC and here SR is also parallel to AC. Since PQ and SR both are parallel to AC, that means they are also equal. Okay, so this one from equation 1 and 2 we get PQ is parallel to SR. In similar way you can see that this PQ is half of AC and similarly SR is half of AC, so that means both are equal to the half of AC, that means they are also equal. Okay, that means, and PQ is equals to SR, so therefore PQRS is a parallelogram. Reason for this one is opposite sides one pair of opposite side is equal and parallel. Okay, so I'll write the reason here. One pair of opposite sides is equal and parallel. That's why PQRS is a parallelogram. Okay, so for what we have done here is we have proved that this PQRS is a parallelogram. Okay, what we have to prove, this PQRS is a rhombus, and we know that in a rhombus all four sides are equal. Since we have proved that it's a parallelogram, so its opposite sides are equal and parallel. Okay, so now we have to prove that one of pair of its adjacent side is equal. That means this will prove that the PQRS is a rhombus. Okay, now let's start. In rectangle ABC, in rectangle ABC which is given to us, ABCD, we have that opposite side of the rectangle are equal. That means AD will be equals to BC, which are why, because they are the opposite sides of rectangle. Opposite sides of rectangle are equal. So we got side AD equals to BC, and if you find the half of the both side, or half of AD will be equals to half of BC. Okay, so half of AD we can write, instead of taking this AD, half of AD we can write this part AC. Okay, in similar way half of BC we can write this side QR. Okay, that means this SA is equals to QR. This will give us, this implies that AS, which is the half of AD, is equals to BQ, which is half of BC. Okay, now let's come to these two triangle, this APS and triangle PBQ. Okay, now let's come to the triangle. In triangles APS and triangle BPQ, we have, what we are going to do here is, now we are going to prove that these two triangles are congruent. Okay, once you prove that these two triangles are congruent, then their corresponding side, this one and this side, will be equal, and hence this PQRS will be a rhombus. Okay, so first we are going to prove that these two triangles are congruent. So in triangle APS and BPQ, we have that AP is equals to BP, because P is the midpoint of AB, because P is the midpoint of AB. That's why AP and BP are equal. Then we have the angle PAS will be equals to angle PBQ, and region for this one will be each of 90 degree. Okay, we know that it's given us in the question that ABC is a rectangle, so its both angle will be of 90 degree. Okay, as we know all the angles of rectangle are of 90 degree. So we got one side, one angle. Now we will look for the another side. So we have already taken that AS equals to BQ, so we have this AS equals to PQ. Okay, which is proved above. So what we got is, we got side, one angle and one side, so these two triangles will be congruent. Okay, therefore triangle APS is congruent to triangle BPQ, and that's by side angle side congruence rule. Okay, so since these two triangles are congruent, this implies what it implies is that this side PS and PQ are equal. The side PS is equals to PQ. This is by property CP/CD, that is corresponding parts of congruent triangle are equal. So since we proved that the PS is equals to PQ, which is these two side of this quadrilateral PQRS, of which we have already proved that it's a parallelogram. So therefore, or you can write and that PQ is equals to SR and PS is equals to QR, which are the opposite side of the parallelogram, opposite sides of parallelogram. Okay, this implies what it implies that we have this PQ equals to SR and PS equals to QR, and we already have PS equals to PQ, so this implies that all four sides of this parallelogram are equal. That means PQ is equals to QR is equals to RS is equals to SP. Okay, hence PQRS is a rhombus. Okay, that's what we were asked to prove here, that PQRS is a rhombus. So that's the solution of question number 3 of exercise 8.2. So with this we have concluded this session. Okay, we'll do the remaining question in the next session. So that's all for now. Thanks for joining here, everyone. Thank